Okay, so for part A, you should have been good, right? Finding the second derivative. Okay, so for part B, it says let f of x be the particular solution, which is annoying because you can't find it because this is not a separable equation. Did you guys notice that? So f of x, you can't find it. You can't actually find the equation, whose graph passes through the point -2, 8. Does the graph have a relative maximum, minimum, or neither? And then justify your answer. Okay, so what do we know about relative maxes and mins? Their slope is 0. So what could we consider about the problem so far that could help us here? Yeah, so they're saying when they say y equals f of x, dy dx is the derivative of y. And so if part B is saying think about f of x, then this would be f prime of x. Okay, so we need to check first to see if this equals 0. And if it equals 0, then you could say it's a relative min or max. How could you determine which one it is? Look at your second derivative, because what does your second derivative tell you? Concavity. So if it's concave up, then you can make an assumption. If it's concave down, you can make an assumption. Okay. Part C, so now they're saying let y equals g of x be a particular solution. So now that dy dx is going to be considered to be g prime, and that d2y dx2 is considered g double prime. Does that make sense? So what is the key? What ends up happening in part C? L'Hopital's, okay? So with this one, you have to be real careful that your notation is perfect so that you can get the points for L'Hopital's and not be marked down. So 0 over 0 should be nowhere on your paper. If 0 over 0 is on your paper, you automatically don't get points for the answer, okay? So this is L'Hopital's, and you're being careful to remember that this is G prime and this is G double prime, okay? And then when you get down here, now they're saying that this is actually H prime, and they're asking you to do Euler's method. And so this one I think is pretty straightforward if you can remember the chart for Euler's method. All right, do we need to go through the chart? Yes? Okay. So to make the chart, you have x old, y old, delta x, and what's your delta x for this problem? 0.5, because you're starting at an x value of 0, and you're going to an x value of 1, and you're doing that in 2 steps. Okay. And then what comes next? dy dx, or whatever could give you your slope. So you're going to go up here to dy dx, right? And then what's next? You're very, very close. Think about... Yeah, and it's kind of like mx plus b is what it is. Okay, and then what's last? Y new. Okay. So you have to work your way through that. And be real careful with your computations because you're not using a calculator for this. Okay? All right, so that's number 4. Very conceptual because it's asking, it switches notations 3 times, and it's really getting at, do you understand all the different places a derivative can be used and a second derivative can be used? And they really make you do like a bunch of different things with it. Okay, so, all right, number 5, this one I think is, when you look at it, it feels ridiculously hard, but it's not as bad as it seems. So I think for part A, we're okay. Average value of radius, that should have been a gimme. Not the easiest answer to find because you do have to do it by hand, but we should have been able to get that one. The hint that I wrote on the board for volume of a funnel was you need to think about the formula for finding volume from way back when, of like your whole life. When you find volume of things that go straight up and down like that, is we do the area of the base times the height, right? So what shape is the area of the base? It's a circle, right? So we have area of a base, which is a circle. What's the area of a circle? Pi r squared. So the volume of the funnel is going to have to do something with pi r squared times h. Okay? you have to think about this in connection with how do we add things, because these are all changing, right? All the radiuses are changing depending on what the height is. And so that's what derivatives and stuff like that, that's what calculus allows us to deal with. So we couldn't do this problem if we didn't have calculus, like derivatives and integrals and all that. But this is telling us we're going to take a bunch of little slices, right? Like I want to take this circle and this circle and this circle and this circle, and I want to add them up. How do I repetitively add things in calculus? You integrate, okay? So to do this problem, you need to have a pi r squared, you need to be integrating something, and you have to think about what the pieces of an integral mean. So how do you include the bounds, the lower bound and the upper bound? What does the function that you're plugging in, what does that mean? And then the notation, you always have to include what does that mean. So if you can conceptually think your way through this problem, you can do this problem. You just had to think a lot about it, okay? So calculus speaking, I'd say that the difficulty between part A and B are about the same. They're both obnoxious to do by hand, but with part B, you kind of had to come up with that formula on your own, which is what makes that a tough piece of the problem, okay? So I'm going to let you guys think through that more before I talk more about that one, okay? Because I think you can get it, but you are going to have to think about it. Part C, they are discussing radiuses and heights and rate of change of radius and rate of change of height. And so when you look at that, you can just use this equation to get there. You don't need a volume equation because they don't talk anything about the volume or the rate of change of the volume. You only need this equation to be able to do part C. Okay, so part C is a typical, I think, related rates problem. Yeah, definitely. Okay, so I'm going to let you guys keep working on that, but at this point I'm going to say, like, you can talk, whatever. When you get done with that, go ahead and work on multiple choice. I do have the rubrics for you guys to grade those, but I would like you to see if you can get further on your own before you look at the rubric, okay? And then when you guys are to the point where you're ready for me to share my answers, let me know and I'll talk through what I did. Sound good? Okay. So here's your music. So, derivative, pretty easy. Yeah, just making sure you get that dy dx piece. And in theory, they've said that if you make a mistake and you use that mistake later on, they won't mark you down for that as long as it didn't make the problem easier. So if you thought the derivative was 2x minus 1/2, you probably wouldn't get all the points later because that does make the problem a bit easier, I think, for you later on. But if you had a second derivative that was still kind of complicated, you'd probably be okay for the rest of the points, the rest of the problem. But that is something that they've said, is that if it does make it easier, they do mark you down. So there is a relative max at -2/8, and that's because if you plug it into the derivative, you get 0, so you know that there's a max or a min there. If you plug it into the second derivative, you get a negative value, and it's concave down, which gives you that it's a relative max at that point. You don't have to write it in a sentence like I wrote it in a sentence. You doing this work is showing that the reason why there's a max there. All right, so for C, I noticed that it was probably L'Hopital's, so I showed my work carefully. So I said the derivative, not the derivative, the limit as x approaches -1 of the top is 0. The limit as x approaches -1 of the bottom is 0, so I'm going to use L'Hopital's. And then I went ahead and I took the derivative of the top, which is g prime, took the derivative of the bottom, and I got 6 times x plus 1. And then over here I did the work to find my g prime, remembering that g prime for this problem is the same thing as dy dx, and I got 0. And so then I went ahead and I did my notation again. So I said the limit as x goes to -1 on the top is 0. Same thing for the bottom, so I'm going to use L'Hopital's. And then that gave me g double prime on the top and 6 on the bottom. So then I was evaluating the second derivative at that same point, divided by 6. And I got -2/6 or -1/3. Okay. And then for Euler's method, using that chart, you have the point 0, 2. Your next point should be 0.5, 1.5, and then your answer should be 1 and 1.25. if you did that correctly. So, and what I'll probably do is I'll scan this and put this up so that you can check. Well, you're going to check the rubric in a second. I'll make it available to you if you guys want to come, if you got a little mistaken. 5/4, yes. Yeah, 5/4. Yeah. Okay. For part A of the question number 5, you had to do 1 over 10 minus 0 of the integral from 0 to 10 of r dh. So that was the function for r. And I'm not sure how far down you guys worked it. I think as long as you did at least this, you're good. So if you have the 1 over 200, or even 1/10 times 1/20th, you're probably good. 3 times 10, 1/3 times 10 to the third minus 0. And then anything you chose to simplify after that, you're good. I stopped because I was like, I'm not dealing with these fractions if I don't have to. Any questions on that one? Okay, so the volume one is the one that really is kind of obnoxious. So here we have pi r squared, so I've got pi and then r squared. The dh and the fact that you're using the integral from 0 to 10 takes care of the height. So you don't actually have to multiply by h because the dh, the integral, is taking care of that. And that's your repetitive adding there makes that integral, and that's what makes the height happen. Does that make sense? Yeah.
For the sake of writing the equation. Oh, yeah, never mind, you did it.
Yeah. So here you can see I did the pi, and then I actually plugged in my r squared. So I had 1/20th, I took that out as 1/400th. And then I FOILed 3 plus h squared, and I got 9 plus 6h squared plus h to the 4th. And then I took my antiderivative, and I had 9h, and then 2h to the 3rd, and 1/5 h to the 5th. And then I just plugged them in, and I called it good. I didn't go any further than that. Did anyone get that part? Does it make sense now that you see it, though? It's like, oh. I did this problem last year, and I did not solve it, but I remembered it from last year. I was like, oh, yes, that was that terrible one. And then part C, I took the equation and I went ahead and I found the derivative of it. So dr dt is 2/20ths times h times dh dt. And then I went ahead and plugged in the -1/5 for dr dt and the 3 for the h. And you're trying to solve for dh dt. And so I had 3/10 on this side, so I just multiplied by 10/3 on both sides. And then I got that dh dt is -2/3, and so it was decreasing by 2/3 inches per second. So make sure, like on this question, you could have completely skipped part B and still gotten a lot of points for the problem. So even if you have a section that you're not sure about, you know, skip it, move on, try the rest of it. Okay. Any questions on any of that stuff? Okay. So let me hand out the rubrics.